Okay, I'm going to try to describe the trace protocol in 10 minutes. And I've talked about protocols on the channel before, and I think it's like yesterday I said that there's probably going to be an everything app. That's what a lot of VCs and startup people in the tech industry think. But I don't think it's going to be an app. I think it's going to be some kind of protocol or a bunch of protocols. And I think that we should all be talking about protocols. I think people like Andrew Huberman are talking about protocols for everyday life. And that's kind of what also a self-help book is. It's a bunch of protocols and what to do. A lot of people are finding that online. So I think we're already talking about it, but what I'm proposing is that because of AI and this kind of all these social things that are going on, I think that we should have this kind of protocol, which is my proposal for how we should kind of pass data around on the internet. I should probably talk about this concept called new IPs, which is new internet protocols. And it kind of gets its name after New York because it was the new version of some place called York in England or wherever. I don't actually know, but I like new IPs because it's new internet protocols and also new intellectual properties, which is data is property on the internet. But really, what I want to get into in this video is the trace protocol. So what does the trace protocol look like? It's called trace because it's only 3 parts. Inputs, part 1. Process, which I'll get into this. This is really the bulk of it. And outputs, part 3. So inputs, process, and outputs. So I said that this is the trace protocol. It's 3 parts. Trace stands for temporal. This is where it gets really confusing and complicated. But if you don't get this, and if this just scares you, then just ignore the next 30 seconds. But trace stands for temporal reactive entity system. But if you don't care about that, just think of it like 3 parts. Inputs, what goes into the system, the process, how to describe that system, and the outputs, what comes out of the system. But trace, like I said, stands for temporal reactive entity system. And the reason for that, I'll explain it with an analogy. Think of Google Sheets or Microsoft Excel, any spreadsheet. That is a reactive entity system. Because if you put something in cell A1 or whatever, you put something in a cell, you can write a formula in cell B1 or whatever, and that it reacts to the state of A1. So that's a reactive entity system, Google Sheets or Microsoft Excel. A temporal reactive system, or a temporal reactive entity system, is something that keeps track of the state of each of the cells over time. So imagine you can see the history of each cell inside of Google Sheets or Microsoft Excel, any spreadsheet. That's what this is. And I know it doesn't look like a box and grid or row and grid kind of spreadsheet, and it's not. But instead of thinking of the cells as in rows and columns, think of the cells as cells in real life, where they're all, in different places on some kind of space, and they connect to each other, and their connections determine what reacts to something else. And so that's why I have the circles right here. because ultimately this is like one node or one cell in the trace architecture or protocol, and it connects to other nodes which are the same structure of inputs, process, outputs. So there's other nodes that subscribe to these outputs, and the inputs can be subscriptions to other nodes. So I'll actually write that. This would be a publisher. This would be a subscriber. And those can be modeled in the same way of input, process, output. So that's 5 minutes. So how do we actually use this? So I don't really want to go into the application of it. I do just want to take the time to talk about the model. But you can see how it's like really simple. It's almost anyone. I know I explained it with this complicated technical definition, but you can see how it's only 3 parts. Everyone kind of knows how to use Google Sheets or Excel. Like, you can kind of figure it out if you really want to. But also, if you don't want to do that, you can simply use something like Google Sheets, and most people can at least figure that out. And here's the thing. I think that the protocols and the way that we communicate on the internet should be, we should understand what's going on. And so we should understand where the inputs are coming from in our operating system, and we should understand all of the outputs of our what we're putting out there on the internet, what the impact is, who the subscribers are, what the implications of using the internet are for us. And so I think if we have new internet protocols, new ways of kind of communicating on the internet at some of the base layers, and if people understand that, then we can make a better internet, which is what a lot of people are trying to do that are interested in protocols. So this is the Trace protocol, Temporal Reactive Entity System. There's publisher nodes that publish outputs. Those outputs are used as inputs into some system or process. That system or process produces its own outputs, and there's subscribers to that. So I want to talk about the process a little bit more, and then really briefly touch on how you can actually model this in a user interface. So the process, this is a little bit more theoretical, but it's a, I think, fundamental concept of computer science. And if you understand this kind of system, which is not, Trace protocol is like some special flavor of this kind of input, process, output thing. But really what this is a functional representation. A process is a functional representation. And I'm going to write down functional representation because it is an important word, or a couple words. And what that is, in one simple sentence, is you can describe, it's a description of a process. It's a functional representation, description of a process. So maybe you write in natural language how the process works, which is kind of like what you would pass to an AI agent. Or maybe you write it in Python code, how the process works, and that would be a Python function. Or you can write it in Java code. It's different languages, different ways to represent a process. And I would argue, which importantly, that because of LLMs, we can write functions in natural language now, pretty much. Which I don't think people realize that's what they're doing. So, given that you have this functional representation, what is that actually used for? It's for representing anything. And so if it represents anything, some other good ways to look at this part and what it actually is or could be, it could be a function like a code function. It could be a model, like a machine learning model. That's a system that has inputs and outputs. It could be an AI model. That's why I have AI on here. Also, agent. It could be an agent that takes inputs and produces outputs. It could represent functionally a person. So a person, maybe they have a thing in their, maybe it's just like some software that they have, and whatever this little node is that's doing the processing, that's a representation of that person, like a user in a user database. Or a place or a thing or any concept you can potentially, theoretically represent as a functional representation. And I won't, oh man, that's 11 minutes. Okay, that means I have to stop. So in the next video, I'll get into how you could actually model this in a UI that's not spreadsheets or bubbles. It's kind of different. But the TLDR is that it's like a list, or it's like a feed of content. But yeah, I will get that in the next one. All right. Hopefully this made sense. By the way, ask questions if you have questions. I'll answer them. And yeah, okay, that's it.